Okay, let's dive right into this explainer. Welcome. I am your host, and today we are stepping into the shoes of the ultimate strategist. Think of this session as the wizard's guide to Cambridge physics. Why a wizard? Because structuring your exam answers correctly is exactly like casting a complex spell. If you use the right structural framework, you cast the right spell and you unlock maximum marks on your paper. But if you cast the wrong one, your marks literally vanish into thin air. Right now, I want to introduce you to two archetypical students that examiners see every single year taking the Cambridge Physics Pass papers, specifically code 0625. Imagine them on a split screen right in front of you. First up, we have Alex. Now, Alex is brilliant. Alex knows absolutely every fact there is to know about the universe. But when Alex is asked a simple, straightforward question, what happens? Total overload. Alex fills the entire page with raw physics facts, writing this massive, sprawling essay about dark matter and stellar evolution, but includes absolutely zero structural analysis, no framework, just a brain dump. Then, on the other side, we have Sam. Sam's problem is totally different. Sam completely panics against the clock, rushes through the question, entirely misses the specific command word requirements, and just throws down a totally unformatted random number, crossing their fingers and hoping for the best. Side by side, when the results come out, both of their papers come back just absolutely covered in red pen marks. It's heartbreaking, really. But that is exactly what we are going to fix today. We are going to transform those red marks into green check marks.
Look at this quote directly from the principal examiner reports. It says, "Galaxies in the universe is one of the most misunderstood areas in physics." When the actual examiners who grade your papers explicitly state that a topic is an absolute disaster zone for candidates, we need to stop everything and pay close attention. It doesn't matter if you are sitting syllabus 0625, 0651, 0652, 5054, or 9702. The pitfalls are universally exactly the same across the board. The examiners aren't just looking for you to passively regurgitate some cool trivia you heard on a late-night science documentary. That's Alex's mistake, remember? They are looking for something much deeper. They want to see a highly specific, connected conceptual understanding that you can actually transfer to totally unfamiliar contexts. They want to see that you understand the precise, mind-boggling scale of space, the strictly correct definitions, and the specific physical properties of galaxies and the broader universe. Alex lost all those marks because he didn't give the examiners what they specifically asked for in the command words. And Sam lost easy marks because they just didn't show the procedural working. By thinking like an examiner today, we are going to completely eliminate both of those errors.
So here is our roadmap for the explainer today. We are covering 1. Galaxies and light years. 2. The method mark strategy. 3. The procedural framework. 4. Evaluating physics evidence. And finishing up with 5. Top examiner warnings. It's a packed agenda, so let's get straight to it.
Starting with Section 1, Galaxies and Light Years. Let's build the absolute foundational concepts of the universe that you simply must know before you can apply any exam strategy.
Before we continue, subscribe to our YouTube channel Ace the Exams, at Ace the Exams IGCS, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so it is absolutely essential to understand our exact place in space. Our sun is just one single star out of literally billions of stars residing inside the Milky Way galaxy. Now, let's look at how a question about this foundational concept might actually appear on your exam, and let's think about how our student Alex would attempt to answer it. The command word on the paper clearly says, "State what is meant by the term galaxy." Now, Alex, trying to show off, writes a dense 4-line paragraph detailing how galaxies have supermassive black holes at the center and emit distinct electromagnetic frequencies. Sounds super smart, right? Like a real astrophysicist? Guess what? 0 marks. Nothing. Why? Because the Cambridge mark scheme specifically requires 2 exact phrases to be present. You must mention billions of stars, and you must acknowledge that our local solar system, containing our sun, is located in the Milky Way. When you are asked to define a galaxy, you need to keep it incredibly precise and entirely aligned with the syllabus. You just say, a massive system made of billions of stars, full stop. It is all about giving the examiner exactly what they are looking for without all that unnecessary fluff.
Moving on. This beautifully illustrates a core concept. While the sun is our local star, the other stars scattered throughout our galaxy and beyond are exponentially, unimaginably further away from Earth. And this brings us to a major point of confusion for students like Sam. Let's say Sam reads a question asking to compare the sun to other stars. Sam, rushing against the clock, just scribbles down, "The sun is hot and close, other stars are far." Again, 0 marks. The examiner is not impressed. To fix this, I want to introduce you right now to the PEEL, or PEEL framework. This is the exact structural strategy, the magic spell if you will, that top-tier students use for extended physics answers. It stands for point, evidence, explanation, link. Let's apply it right now. I'm going to give you a 30-second mental timer here to see how you'd structure this. Okay, let's break it down together. First, the point. The Sun is a star situated within our local Milky Way galaxy. Next, the evidence. The physical distance from Earth to the Sun is minuscule compared to the massive distance to other stars. Then comes the explanation. Because of these immense spatial differences, the Sun appears very large and bright to us, while other stars, which are much, much further from Earth, appear merely as tiny points of light. Finally, the link. Therefore, the apparent differences in magnitude we observe are entirely due to their relative proximity to Earth, not necessarily their actual size or luminosity. Do you see the difference? By casting that PEEL framework, you are proving to the examiner that you don't just know the trivia, you know how to structure a logical, compelling, strictly scientific argument.
Let's move into the transformation phase and look at a term that constantly trips people up. Because the distances in space are so vastly, unfathomably spread out, we can't really use standard meters or kilometers effectively. The numbers just get ridiculous. So, we measure astronomical distances in light years. Now, I want you to notice the absolute key word here, distance. Listen to me closely, because every single year, thousands upon thousands of candidates throw away a totally free mark because they state that a light year is a measurement of time. I mean, it makes sense intuitively, right? It has the literal word year in it, so Sam naturally assumes it's measuring time and writes that down. This is exactly why we must decode our command words and definitions strictly. If the command word says define, you state unequivocally the astronomical distance that light travels in one single year in a vacuum. You must be sharp, you must be precise, and you absolutely must avoid those intuitive traps that the examiners intentionally set for you to fall into. We are turning those red marks into green check marks by getting the specific vocabulary locked down.
So just to really hammer home the crucial point here, we need to talk about the sheer, mind-bending scale of a single light year. 1 light year equates to exactly 9.5 times 10 to the power of 15 meters. You absolutely need to commit this specific standard form value to memory right now. 9.5 times 10 to the 15 meters. Seriously, burn it into your brain. Now, think about how you would handle converting a distance given in light years into meters on a real high-pressure test. Imagine an exam question tells you a newly discovered star is 4 light years away, and the command word is calculate. How do you set up that calculation to guarantee you get the method marks, even if you panic and punch the completely wrong numbers into your scientific calculator? Well, you must physically write out on the paper 4 multiplied by 9.5 times 10 to the 15 meters, showing that exact line of working, explicitly stating the multiplier on the page, is exactly what separates the top-tier candidates who get A stars from the rest of the pack.
That leads us perfectly into Section 2, the method mark strategy. Let's see how this theoretical knowledge builds into a rock-solid scoring system. Stop scrolling! Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, look closely at the text for this slide. Notice the phrasing, analytical depth over superficial breadth. This is the exact reason why Alex's strategy of writing down everything he knows fails so spectacularly. Cambridge does not care how wide your general knowledge base is if you cannot string 2 logical thoughts together to actually solve the specific, narrow problem right in front of you. Method marks are your ultimate safety net. They are awarded for showing the correct formula, substituting the correct numbers, and arranging the calculation correctly on the page. Think about it. If you do all of that but your calculator battery dies halfway through and you write down the wrong final answer, you will still get the vast majority of the marks. That is the literal magic of the method mark strategy. It protects you from your own silly mistakes.
Let's move on to Section 3, the procedural framework. Now we are going to reveal the exact step-by-step procedure needed to process these complex physics problems without panicking.
Welcome to the interactive workshop part of our explainer. We are looking at a standardized 5-step sequence that absolutely guarantees you hit those method marks every single time. Here it is. 1. Identify key elements. 2. Apply relevant principles. 3. Execute analysis with clear working. 4. Verify results. And 5. Present in appropriate format. Let's do a live rewrite of one of Sam's disastrous answers using this exact blueprint.
Imagine the 0625 past paper asks, a galaxy is 2.5 light-years away. Calculate this distance in meters. Okay, visual timer starts now. 60 seconds on the clock. Step 1. Identify key elements. Sam scans the text and highlights 2.5 light-years and the target unit meters. Step 2. Apply relevant principles. Sam takes a breath and recalls our golden number. 1 light-year is 9.5 times 10 to the 15 meters. Step 3. Execute analysis with clear working. Instead of just doing it in their head, Sam explicitly writes down the formula on the dotted lines. Distance equals 2.5 multiplied by 9.5 times 10 to the 15th. Step 4. Verify results. Sam checks the calculator screen twice to ensure the standard form was actually entered correctly and didn't miss a zero. Step 5. Present in appropriate format. Sam writes the final, calculated answer clearly, making absolutely sure the unit meters is written at the end. By simply slowing down and meticulously applying this 5-step framework, Sam just secured 100% of the marks. This is the physics success blueprint in real practical action.
Knowing the procedural steps is fantastic, but for Section 4, Evaluating Physics Evidence, we need to level up and look at how to critically analyze and evaluate complex data.
I absolutely love this problem-solving visual story method. It's called deconstruct, solve, evaluate. You deconstruct the raw information, break it into logical steps, solve systematically, check if your answer is even reasonable, and finish with a completely justified recommendation. Let's do Challenge 2 of our workshop. Find the flaw. I want you to apply this rapidly. Imagine you are staring at a highly complex data table on your exam. It shows the distances of various distant galaxies from Earth on one axis and their respective speeds moving away from us on the other. Your deconstruction phase should instantly, within seconds, isolate the core trend. As distance increases, the speed of recession increases. Now, what if you see a written claim from a student like Alex on the paper, saying, the data shows galaxy X is 5 light-years away. It is moving fast. Therefore, all stars are in the Milky Way. I'm giving you a few seconds. Spot the flaw. Did you get it? Your evaluation step should instantly spot the massive logical gap. The conclusion Alex drew has absolutely zero logical link to the given data, and it actually actively contradicts the fundamental definition of galaxies we learned 10 minutes ago. Alex completely failed to break the data into logical steps and evaluate it properly. Now for Challenge 3, speed writing. You have 30 seconds to write one perfect PL paragraph refuting Alex's claim. Go. Time's up. If you used point, evidence, explanation, and link based on the data, you nailed it. This rigorous deconstruct, solve, evaluate cycle is exactly what elevates an average rote memorization student into an absolute master of Cambridge physics.
When you are evaluating the quality of evidence in your exam, you must systematically put on your detective hat. You need to actively look for limitations, spot the hidden assumptions being made, determine if there are alternative interpretations of the data, and evaluate their ultimate effect on the final conclusion. You see, in the absolute highest level past paper questions, Cambridge isn't just going to ask you to punch a number into a formula. That's too easy. They're going to give you a flawed experiment or a messy set of astronomical data and ask you to evaluate it. So ask yourself, are there actual physical limitations to measuring distances that span billions of light years? Absolutely there are. What massive assumptions are being made by the scientists about the speed of light traveling through different cosmic mediums over billions of years? Could there be totally alternative interpretations of the redshift data they provided? If you can articulate these limitations clearly and logically on paper, you're demonstrating the exact, high-level, connected conceptual understanding that the principal examiner reports are desperately begging candidates to show.
Moving into our final section, Section 5, Top Examiner Warnings. We are pulling back the curtain on the final system you need.
You must avoid these specific traps at all costs. Let me present to you the complete, finalized physics answering system. Think of this as your ultimate cheat sheet, containing the 3 absolute rules that guarantee top marks every single time. Rule number 1, command word decoding. You must obey the verb. If the paper says state, you just give a brief, factual sentence. If it says calculate, you deploy the full 5-step procedural framework we just practiced. Rule number 2, Peel framework application. Never ever just dump a random assortment of facts onto the page like Alex does. Always use point, evidence, explanation, link. Keep it structured. And rule number 3, the time management matrix. Please do not be like Sam. You have to look at the specific marks allocated for the question on the right side of the page. If it's a hefty 4-mark question, you need to spend the proportional amount of time setting up the calculation, clearly showing the standard form of 9.5 times 10 to the 15, and stating the final units. Skipping the presentation phase just because you feel a little bit rushed is exactly how you throw away an A-star grade.
Let me give you the most valuable exam hack you can possibly take away from this entire explainer today. Always clearly define your key terms, words like galaxy or light year, right at the start before you start using them in an extended analytical answer. It proves to the examiner immediately that you know what you're talking about. Students who implement these physics strategies see an average improvement of 2 grade boundaries. But only if they practice consistently with our weekly videos. When you walk into that exam hall next time, you aren't going to panic. You aren't going to sweat. You are armed to the teeth with the Peel framework, the 5-step method mark strategy, and a crystal clear understanding of the cosmos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by.
So I leave you with this final thought. How will you actively apply the deconstruct, solve, evaluate method to your very next physics past paper? The magic of these frameworks only works if you actually cast the spell yourself. So as you open your next practice test this week, ask yourself, are you just writing down random facts hoping something sticks, or are you proving to the examiner exactly how a true physicist thinks? Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.